Hey, Advanced Math. I want to talk more about scaling and scale drawings, scale factors today. I want to talk about what happens to area and perimeter of things when you do that today. Oh, but I'm on the wrong screen for you because I don't have my thing, so I need to do it by hand. So, area and perimeter when a drawing is scaled up or down. Let's go ahead and make this the title of your next and getting toward the end of your math notebook here probably. And unpause when you're done and give me your total concentration until we get to the we do. So, here's an example we did the other day where we took this triangle that was 4 inches this way, 3 inches this way, 5 inches this way. And it was similar to this triangle, which is 3 1/3 this way, 2 inches this way, 2 2/3 this way. And we found out that they had a scale factor of 2/3. This one was 2/3 the size of the larger one, right? 5 times 2/3 was that. 3 times 2/3 was that. 4 times 2/3 was that. So it's in the same proportion to this one, but everything is scaled down by a factor of 2/3. And so what I want to talk today about is, well, when you do that, how do the area and the perimeter of the triangles change when you scale something up or down? So, if I look at the big triangle here, the perimeter is the distance around it. Add the sides up, so 5 inches plus 3 inches is 8 inches, plus 4 inches is 12 inches. And the area, a little quick review, the area for a triangle, remember we would double them into rectangles. Find the area of the rectangles and divide it in half. So the area of a triangle was the length times the width divided by 2. So in that case, this 5 would not factor in, so that would just be the length was 4, the width was 3, and divide that by 2, you get 12 divided by 2, you get 6. So the area is 6 square inches, right? And so then my question is, if I scale it down by a factor of 2/3 to that smaller one, what's going to happen to the area and the perimeter? Is the area going to be 2/3 of this area? Is the perimeter going to be 2/3 of this figure or not? Or does that change even more than that? So this one had a perimeter of 12, area of 6. Let's see what happens when I get over to the smaller one. So this one, already the work's been done. So I've got a scaled down by 2/3 drawing. Let's start with the perimeter over here. The perimeter is 3 1/3 plus 2 is 5 1/3 plus 2/3 is 6 plus 2, 7, 8. So the perimeter here is 8 inches. And you'll notice that follows my scale factor, right? 12 times 2/3 is in fact 8. 12 times 2/3 is 24/3, which is 8. So that followed the scale factor exactly, and that makes sense, right? If every side is 2/3 of the length over here, then the perimeter should be 2/3 the length of this one over here. So that one's not too surprising. The area is a little different. So here, I'm going to have to do my formula here. Area equals length times width divided by 2. This is going to be a little more work because I've got a fraction in there. I'm going to do that work down here. So length is 2 2/3 times 2 is my width. I could do this all with fractions, or I could do kind of a number talk kind of strategy here where I double the 2 and I double the 2/3, which I think I'll do. 2 times 2 is 4. 2 times 2/3 is 4/3, and I can't leave it like that. So I would change that to 5 1/3. And so that's length times width, and I have to divide it by 2. Let's see, this is going to be too hard to do that way, I think, so I'm going to go ahead and make this improper fraction. I'm going to make that 16 thirds divided by 2, which is the same as times 1/2, which is 16 sixths, or 2 4/6. So this one has an area of 2 4/6. That is not 2/3 of 6. So I didn't follow my scale factor here. My area changed by a different amount. 2/3 of 6 is 4, and my area was actually quite a bit smaller than 4 after I scaled it down. So what I want you to know, perimeter follows the scale factor. Area does not. The perimeter of this triangle, the small triangle, is just 2/3 of the big one. If that were true of area 2/3 of 6 would have been 4, and we got way less than 4. So actually, when we scaled this down by 2/3, we scaled down the area even more than that. So area did not follow the scale factor, and that's an important thing to know. Let's do one together. I think when we scale something up, you'll be able to see how the area does change a little more clearly. So open your notebook. This is another example we did yesterday. Landscape architect is designing a new park for his community. To design it, he's using a scale of 1 centimeter represents 10 yards for the actual park. What will be the area and the perimeter of the actual park? So notice they don't even ask. Yesterday I asked you the dimensions. Today I don't even ask you the dimensions. I just go straight to the area and perimeter for the real park. So this park was, the drawing was 8 centimeters this way and 5 centimeters this way, if you count the line segments on the graph paper. And so we had a length of 8 centimeters and a width of 5 centimeters. And we said here, we want to change this 1 centimeter in the drawing is proportional to 10 yards in the actual park. So it's like a 1 to 10 ratio. So what I'm going to do, I'm going to take my 8. We did this yesterday, so if I say that's my original ratio for my 8 centimeters in the drawing, how many centimeters would that, or how many yards rather, would that be in real life? Well, that was times 8, so this was times 8, and we said it was 80 yards. And likewise, this other dimension is going to be 50 yards. So it's a 50 yards by 80 yards for the actual thing. So when I check the perimeter here, let's think about the perimeter first. So the perimeter of the drawing is 5 plus 8 plus 5 plus 8. So that'd be 16 plus 10 is 26 centimeters. And so my scale factor, remember, was 10 here. I'm scaling this up by 10, basically. You know, to get from 1 to 10, I just go by 10. And when I check my real one would be 80 and 50 down from here. So my real one would be 80 plus 80 plus 50 plus 50. That'd be 160 plus 100. So the real park would be a 260-yard perimeter. And you'll notice that does follow the scale factor. Perimeter does follow the scale factor. All right, so if you know that the park is being scaled up by a factor of 10, 1 to 10, the drawing's going to have a certain perimeter, and the real one will be 10 times more. It follows the scale factor exactly. So you could just say, as long as you find the perimeter of the small one, you can just scale it up by 10, you'll get it. Area, different story. The area is not going to be 10 times the area of the drawing. The area of the drawing, it's a rectangle, so it's pretty easy to do. Length times width, or base times height, would be 8 times 5 is 40 square centimeters. And if we followed the scale factor, we'd say, oh, well, then the real one's going to be 400 centimeters because there's a scale factor of 10, right? That's what we would expect to see. Scale factor is 10. But that's actually not what we're going to see. It's not going to be 400. I actually want you to write 400 there because I want you to remember that that's not it. The area is going to change by quite a bit more. So if I go up to my drawing on here, my real drawing is 80 by 50. So it's going to have the real one's going to be 80 times 50. So 8 times 5 is 40. But I've got to add 2 zeros from the 80 and the 50. So it's not 400. It's 4,000 square yards for the real park. So I didn't scale it up by 10, I scaled it up by 100. So area does not follow the scale factor. All right, so perimeter does follow the scale factor, area does not follow the scale factor. That's what I want you to know for today. I'm going to talk exactly about what does affect the scale factor tomorrow, or in the next lesson. But what I really want you to get by today is like, okay, if I scale something by a half, the perimeter is a half. If I scale something by 12, the perimeter is times 12. But area doesn't work that way. Area, it changed quite a bit. Here we scaled up by 10, but our area changed by way more than 10. In the last example, we scaled by 2/3, but our area changed by a lot more than 2/3. So area doesn't follow the scale factor. We'll get to exactly what and why it does follow in the next lesson, but I just wanted to get you thinking about area and perimeter and how they change today. If you need to go back and watch anything again so you have a great understanding of this when you get to class, please do, and I'll see you tomorrow.